Okay, lesson 7-6. We are solving rational equations and inequalities. A lot of what we did before winter and spring break, where we found the least or lowest common denominator, and we used that before spring break, or in winter, we were using the LCD to add or subtract two fractions. Today we're going to use the LCD to help us take rational equations, that just means fractions, equations that contain fractions. We're going to get rid of those fractions. And that's going to be true for inequalities as well. So just a quick preview. Let's just jump right in. So your knowledge of how to find the LCD is going to be big. It's going to be very important. So let me just do this first one with you. I'm looking at the denominators and I'm trying to figure out what the LCD would be. And what I've come up with, and make sure you understand where I get this, the LCD will be 12 times x minus 5. What I've done here is I've chosen the lowest factor that each of these denominators will divide into evenly. Any questions on how I got the LCD? So what I'm showing here in red is I'm going to multiply both sides of this equation by the LCD. The purpose of this, the reason for this, is I want to get rid of, I use the word clear, I want to clear out all denominators. Remember, the goal is to take an equation that has fractions and turn it into an equation that has no fractions. Does anyone in here like fractions? Okay, that's what I thought. Well, since we don't like fractions in general, I mean, I do, but most students don't, let's get rid of them. And here's how we do it. Just very much like we did previously, I'm going to divide this denominator, this blue 3, I'm going to divide it into my red LCD. When I divide 3 into 12, I get 4. And now I'm going to take that 4 result and I'm going to distribute to x minus 5. Okay, so one step at a time. I've divided 3 into all of this, and I get 4x minus 20. Okay, let that sink in for a second and let me know if you don't understand where I got 4x minus 20. Okay, now I'm going to take 4x minus 20, the result, and I'm going to multiply it by the numerator 7. Yes? Question? Well, it started with dividing 3 into all of this, and that makes 4. And now I just distributed 4 to both of these. Good question. Everybody else? Everybody good? And now that we've got 4x minus 20, the result of division, we need to now multiply by the numerator. So both of these multiplied by 7 gives me 28x minus 140. The denominator has basically been swallowed up. If you want to look at it that way, I've got to get rid of it, and I let it get swallowed up by the LCD. I'm going to do this same process with the next fraction. This is a lot of repeat, a lot of repetition. Same process over and over and over again. Okay, let me erase my work that we used for that first fraction. I'll just put it back the way it was. And now let's do the same thing with the next fraction. This time I'm dividing x minus 5 into the LCD. The x minus 5s would cancel, leaving 12. And just like I did before, I'm going to multiply 12 times 3, and I get 36. I'm done with the left side of the equation. Now I'm going to jump over to the right side of the equation, do the same thing. This time the 12s will cancel, and I'm going to multiply 19 times x minus 5. And that gives me 19x minus 95. So notice, started off with ugly fractions. Using the LCD multiplied on both sides, I have no fractions. This is almost like an Algebra 1 equation. I got to combine like terms. Here's my result of combining like terms on the left side. Question? 28x. Okay. Going back over here, You divided 3 into all of this. 3 goes into 12 4 times. Now divide or multiply 4 times both of these. Okay? And now we've set up this being multiplied by 7. You always divide and then multiply times the numerator. Does that help you? Okay, everybody with me so far? I've combined like terms, and now I'm trying to get x on one side only. So without showing a lot of steps, I'm going to subtract 19x from both sides. And I'm going to add 176 to both sides. And I get down to my final, at least I think, it's a final solution for x. X is 9. Now, if you notice the directions, I just took them straight from your book. It says to check your solution. Well, once again, I'm not going to look at your paper and make sure that you wrote down your check, but it's going to be on you if you choose a number that you say is a solution, and then you go up and you plug that number in for x or whatever the variable is, and it makes 0 in a denominator, and you said it's a solution, then it's going to be counted wrong. Because if we say the number is a solution, then it should not create 0 in any denominator. Now that does not happen here, obviously, because if x is 9, this denominator becomes 4. Obviously, we can divide by 4. So you at least need to do a visual check. Doesn't have to be anything you necessarily write down, but you should at least verify that your number for your solution does not create division by 0. Any questions on our first example? All right, let's try letter B. So does anybody want to give me the LCD? John? 12 times y plus 3. Very good. So I'm showing his LCD here being multiplied on both sides. So you just start that process. So you get a lot of practice with the process. This one looks a lot like the previous problem. Let's see, Matthew, if I divide this blue denominator 4 into the LCD, what's the result of just that part? And can you go ahead and do that? 3y plus 9. Is everybody good with what Matthew just did? Okay, Matthew, take it one more step and multiply 3y plus 9 times 11. Very good. Okay, I'm going to jump over to Izzy, and with the next fraction, do that same process. Divide blue into red. Blue denominator into the LCD. What would you get? It's all right. Do you notice the y plus 3's cancel? Leaving 12. So what are you going to do with 12? You're just going to multiply by 5. You just always, once you do the division and you find out what the result is, you take that result and multiply by the numerator. So 12 times 5 is 60. All right, Meredith on the right side. Y. 23y. Might be kind of big. 23 times 3. If you need a calculator, raise your hand and I'll get one. 69? Okay. Why don't you just pass those around if you need it. Go ahead and do the trade. Okay, well, we've accomplished getting rid or clearing out all the denominators, so now it's back to familiar territory. We're going to try to get y on one side only, but we need to combine like terms first. If I subtract 23y from both sides, I get 10y on the left. And if I subtract 39 from both sides, I get 30 on the right. Divide by 10, and I think the solution is y is 3. But I'm going to do a quick check. And I notice that 3 does not create 0 in any of these denominators. When I plug in for y, there's only one denominator that has y. So that ends up being my final solution. Any questions? Are you good so far? Okay, let's try letter C. I still need to find the LCD, but to find the LCD, you really need to have all of your denominators factored first. And this right side denominator needs to be factored. So before I go any further, instead of rewriting the problem, I'm just going to show the factored form of this right denominator. Because there are factors of -6 that add up to +1. Okay, so I'm just going to mark out this trinomial, and we're going to replace it with the product of these two binomials. Now it makes it pretty easy to find the LCD, which hopefully you can recognize it as x plus 3 times x minus 2. And I'm going to show that being multiplied on both sides. All right, back to the process. So I'm going to divide blue into red, blue denominator into the red LCD, and let's see, Keegan, what is the result of that division? This blue denominator into the LCD. Good, and what are you going to do with x minus 2? And what is that? Awesome. Okay, Abigail, next fraction, same thing. Good. So you divide x minus 2, the x minus 2's cancel, 10 times x plus 3, 10x plus 30. And Sam, what's the right side of the equation going to become after multiplying? Very good, because when you divide the LCD into itself, any number divided by itself is just 1. 1 times 122. And we're back to, again, familiar territory, combine like terms. I just did 14x plus 10x, negative 28 plus 30. We're going to subtract 2 from both sides. And when we divide by 24 on both sides, we got our potential solution. Just a quick check. 5, when it's replacing x, does not create 0 in any of these denominators, so that looks like a good solution. Any questions on letter C? You guys are doing great. Any questions? Okay, I think I got one more before we move to inequalities. Hello? Sure. Kennedy, Miss Morris needs to see you after class. All right, so once again, I've got this situation where not all of my denominators are factored. So I'm going to show the factored form of this right side denominator. Just makes it easier to find the LCD, which ends up being x plus 2 times x minus 2. I'm going to show we're going to multiply by that on both sides to clear out the denominators from the original problem. Make this easier to work with. When I divide blue, x plus 2, into red, you see how the x plus 2's would cancel, leaving x minus 2 times 5, which is 5x minus 10. Be careful here. Heads up here. I've already had some people make a mistake, and it's easy to make. When it comes to subtraction, when I divide x minus 2 into the LCD, I get x plus 2 as the result, times 3, 3x plus 6. 3x plus 6 is all subtracted. Okay? So what I would always recommend when you are subtracting and it's a binomial or trinomial higher, something higher than a monomial, I would always recommend that you put this in parentheses as a reminder. Not only are you subtracting 3x, but you're also subtracting 6. That's key to getting this correct. Any questions there? And then the right side of this equation is just going to be 12. So when I combine like terms, 5x minus 3x is 2x, and negative 10 minus 6 is negative 16. So I can't stress this enough. Subtracting binomials or higher, meaning more terms. Don't forget you're subtracting every term in that polynomial. All right, so 2x is equal to 28, and my final answer, I think, is 14. And that doesn't create any zeros in any denominator, so we are good. All right, we're going to leave equations, and we're going to talk about inequalities. So any questions so far? Yeah.
Instead of doing it in like the little parentheses, could you just like set up minus sign?
Yeah, if you distributed negative 3 instead of, is that what you're saying? Yeah, it sounds like, if I heard you right, you could have distributed negative 3 instead of positive 3, and then you wouldn't need parentheses. So, right, it'd be negative 3x minus 6. Yeah, good question. Anyone else? Okay, let's talk about inequalities. They're a little different, a little more involved in these. The first thing that you should always do when you're solving an inequality is identify if there's a variable in the denominator, and obviously that's what we have here. We need to identify, first of all, what this variable cannot equal. Remember, we're always trying to avoid division by 0. So right off the bat, I'm going to say that C cannot be 0. If it is, then we have an undefined situation. Okay, so we've identified what the variable can't be. Now we're going to temporarily treat this as though it's an equation, just like we did before. Okay, so I am going to approach this as though it said 1 over 4c plus 1 over 9c equals 1/2. And I'm going to use those same steps, the same procedure that we just used, I think 4 different times, to solve for C. So let's start with the LCD. Riley, what's the LCD here? $36C is correct. I'm going to multiply by 36C on both sides. So Jalen, this first fraction after multiplying by 36C will become 9. Good. Kennedy, the next fraction will become 4. On the right side of the equation, Meredith, what will this become after I multiply 1/2 times 36C? Or you could think of dividing 2 into 36C. 18C. Very good. The C's cancel. Yeah. Okay, solving for C, dividing by 18 on both sides. We end up with this number. If we were treating this as an equation, that would be our solution. Well, here's where inequalities get different. And we've done this in the past. You may have forgotten. I'm going to take the number that we said C cannot be right off the top, the number that we got if we treat this as an equation, and I'm going to put these on a number line. So here's 0, and here's 13/18. And basically these two numbers break my number line up into 3 sections, or areas, or intervals, whatever term you want to use. And now we're going to pick a number in each area to test. So a number that is less than 0, and I'll put my test numbers in red. For example, negative 1, that's obviously less than 0. 1/2 would be between 0 and 13/18 because isn't 9/18 1/2, and that's certainly within this area. And then we could just use the regular 1 over here in this interval. Okay, everybody with me? So here's what we're going to do. We're going to take each of these red test numbers, and now we're going to go back to the original inequality. And we're going to see if plugging those numbers in for C, the red test numbers, do they make this true? All right, so let's test. If C is negative 1, that makes negative 1/4. 4 times negative 1 is negative 4. If C is negative 1 here, that makes negative 1/9. And I'm going to put a little question mark because we're trying to decide, does this left side, is the left side less than 1/2? Well, it's pretty obvious. If you add two negative numbers, what must be the sign of the answer? Negative. And negative anything, even if you don't actually add those together, a negative number has to be less than positive 1/2. True? So what we've proven here is that the numbers that fall in this range, less than 0, work. Now let's try in between, and we're going to use 1/2 as the number to try. And if you want to just grab your calculator, it's probably a good exercise for you. If you need your calculator, go ahead and let C be replaced with, if you want to use 0.5, that would be okay. See if you can determine if letting C be 0.5, does it make a true statement in this inequality? So I'm going to give you a few seconds to do that, and then I want to see what your answer is. Anybody want to volunteer an answer? Raise your hand. You do? Kennedy, what'd you get? Yes or no? Doesn't work. How many of you agree? These do not work. Raise your hand if you agree. How many of you don't know for sure how to tell? Okay. Let's grab your calculator. And we'll just use 0.5. I guess we can use parentheses too. I will try without. Maybe we should use parentheses. Say it again. Yeah. It's, to me, I think of that as 1 over 9/2, which is really 2/9. Dividing by 9/2 is really multiplying by 2/9. Does that answer? Yeah. To me, it's easier to do without the calculator. I know some people struggle a little bit with fractions, so let's try it with just fractions. Does what I have there make sense, Matthew? Yeah. Okay, so you can probably tell already 1/2 plus anything has to be greater than 1/2, right? Even without going through the whole process of actually getting a common denominator, you can tell that that's not going to work. Okay, does that help? Everybody with me? Okay, what about the right side? If you let C be 1, 1/4 plus 1/9. And if you need to change these into common denominators, 1/4 is 9/36. And 1/9 is 4/36. Is that less than 18/36, which is 1/2? Yeah, if two fractions have the same denominator, then the one with the lower numerator is the lower fraction. Remember that? Heard that from elementary school? So we've proven that by testing 1, we've proven that this interval to the right of 13/18 works. So we're about ready to write our final answer. You ready? Based on this number line, here's my final answer. The numbers less than 0 are part of the solution. That's what we've checked off here. And we could also say the numbers greater than 13/18 are part of the solution. That's how we've indicated it with our little check mark here on the number line. So, it's the first time you've seen that, maybe. Any questions? Let's try another one. I think we're doing good. Let's see. Kennedy, give me the LCD. Good. 15x. Change color if I can. So let's, getting a little bit ahead of myself. Kennedy, give me the number that x cannot be. All right, let's start there. Identify what x can't be in this problem. And we're going to turn this into an equation temporarily. And Kennedy gave us the LCD, 15x. Okay, so Matthew multiplying the first fraction by 15x gives us 75. Good. John, the second fraction multiplied by 15x. Close. What happens to the x's? Okay, there you go. Very good. And let's go over to Izzy. The right side of the equation will become what? If you divide, say it again. 10x, good. Good? Okay. And pretty simple to solve for x. I'm going to change it into the decimal 9.3, just 93 divided by 10 in your calculator. All right, let's make our line. And we're putting the numbers 0 and 9.3, and we're testing all around those. We're testing the 3 areas that are made up from those 2 numbers. So you can pick any number you want, as long as it falls in those 3 areas. I typically just go with the closest one, -1, or the easiest one, +1, 10. So I'm going to give you a few minutes, and I want you, this is important that you're able to do this. I want to see if you can see which one of these red test numbers makes our red original inequality true. Left side has to be greater than 2/3. So, all right, so you've proven that these on the outsides do not work, hopefully. And the middle does. And so here's how we're going to state our answer. Please don't just show me this as your answer. You need to interpret this number line in an inequality statement. And it should be all of the numbers between 0 and 9.3. So who got that right? Very good. You guys are doing really good. Questions? Okay. Let's see if we can work on letter C. Thank you. First of all, let's identify what x cannot be. Jalen, what is x not allowed to be in this? X can't be 2. All right, that's going to be one of our numbers on the number line. Abigail, what's the LCD? When we change this into an equation, we're going to multiply by what on both sides? Very good. She said 12 times x minus 2. 12 times x minus 2. Okay, now that we've found the LCD, and we're going to multiply by this LCD on both sides in order to clear out all denominators. So starting with this first denominator, 3, dividing into the LCD, 3 goes into 12 4 times. Let me see if I can just do some canceling here. This would become 1, and this would become 4. And now I'm going to go ahead and multiply 4 times this quantity, and I get 4x minus 8. Okay, so we want to look at that. And now, after dividing 3 into the LCD and getting that result, we're going to multiply 4x minus 8 times x, and that's 4x squared minus 8x. All right, so let me erase my work here involving that first fraction, and we'll just put it back so that we can use it to work with the second fraction. Okay, now when I divide x minus 2 into the LCD, the x minus 2's will cancel, leaving 12, and I always multiply whatever the result is by the numerator, and so I'll be subtracting 12 times 1, which is 12. And then jumping over to the right side, 4 divided into the LCD, this would become 1, this would become 3. Now let's go ahead and multiply. 3 times the quantity x minus 2 is 3x minus 6. Now we're going to multiply the result times this numerator x plus 1. So we're going to have to use FOIL here, two binomials multiplied together. So 3x times x is 3x squared. X times negative 6 is negative 6x plus 3x, that's negative 3x minus 6. Now, I'm going to put like terms together on the same side. So I'm going to subtract 3x squared from both sides. 4x squared minus 3x squared is x squared. I'm going to add 3x to both sides. Negative 8 plus 3 is negative 5x. And I'm going to add 6 to both sides. Negative 12 plus 6 is negative 6. Now I'm going to solve by factoring, because there are factors of negative 6 that add up to negative 5. Minus 6 plus 1. And solving, I get positive 6 and negative 1. Okay, so I have actually 3 numbers that are going to be placed on my number line, breaking my number line up into 4 sections. All right, so let's just list them in order from low to high. Negative 1, positive 2, and positive 6. Just showing how these numbers break our number line up into actually 4 sections. So let's start testing. You can pick any number you want that falls within these ranges. And I'll just put mine in green. For example, we can say negative 2. A number in between negative 1 and 2, which would be 0. Any number between 2 and 6. I'm going to use 4. Just notice that that would make this a little bit easier. And then a number greater than 6. I'll just go ahead and say 8. All right, so let's test these out. Starting with negative 2, if x is negative 2, then I got negative 2/3. And then if x is negative 2 here, I get minus, and it's going to make this negative 1/4. Okay, subtraction. And then hopefully you can see when x becomes negative 2 minus 2 is negative 4. So be careful, you're going to actually be adding here. And we're going back to the original inequality, and we want to know if the left side will be less than the right side. But we got to plug negative 2 in for x here. Negative 2 plus 1 is negative 1/4. All right, so let's see. Running out of room here. Negative 2/3 plus 1/4. is that less than negative 1/4? So we can come up with a common denominator, which would be 12. 3 goes into 12 4 times, so this is negative 8/12 plus 3/12. Is that less than negative 3/12? Well, negative 8 plus 3 is negative 5, and negative 5 is less than negative 3, so we've proven that the numbers less than negative 1 work out. Okay, let's try 0. I'll just erase all the work needed for that test. Bear with me for a second, and we'll try a test with 0. Okay, 0 over 3 is 0, minus, this is going to be 1 over negative 2, which is negative 1/2. Is that less than, 0 plus 1 is 1, less than 1/4? Well, this is just 1/2, and 1/2 is not less than 1/4, so these do not work. All right, so let's try 4. And I think I'll save a little bit of time because this video is getting kind of lengthy. Hopefully you've seen enough on how to test these, and you definitely do need to test. But the numbers in between 2 and 6 do work. The numbers greater than 6 do not work. So here's the way I would state my final answer. We have all of the numbers less than negative 1, or we have the numbers in between 2 and 6 as solutions. Okay, so this is my final answer for example letter C. Okay, one more, and this will wrap up our notes for this assignment. Let's get our LCD, which would be 9x multiplied on both sides. We're going to treat this temporarily as an equation. Another thing we should do right off the bat is identify what x cannot be. We cannot let x be 0. So if we treated this as an equation, to get our other numbers for our number line, it would look like this. 3x goes into 9x 3 times. 3 times 4 is 12. X goes into 9x 9 times. 9 times 7 is 63. And over on the right side, 9 into 9x goes x times 5 is 5x. So we add these two together and we get 75. And we get 15 to go along with 0 on our number line. And then we start our test. So we have 3 sections. 3 numbers to pull from in these 3 sections. So we'll test negative 1. We can test anything we want in between 0 and 15. I'll just go with positive 1. And then we'll test 16 over here on the right side. Okay, so let's do our negative 1 test. That will be negative 4/3 if x is negative 1, plus negative 7, and we want to know if that's less than 5/9. Well, if we want to convert to ninths, I think it's pretty obvious though, if you have 2 negative numbers added together, that has to be a negative result, and all negative numbers are less than positives, obviously. So this side, this area works, the number is less than 0. If we try 1, we get 4/3 plus 7, and we want to know if that's less than 5/9. Well, that's pretty obvious too without doing a whole lot of calculation, because that's going to be 8 1/3, and obviously that is not less than 5/9. So these within 0 and 15 do not work. And then trying 16, just to save you a little bit of time, if you did plug 16 in, you're going to get these do work. So our solution becomes all the numbers less than -1, or, I'm sorry, less than 0. Sorry about that. 0 is the line that we were testing around. So all the numbers less than 0, or all the numbers greater than 15 will end up being our solutions. Okay, and that wraps up the notes. Kind of a lengthy video, a lot of stuff we covered here. So I hope this helps you, and if you have any questions, let me know.